8894. Why are the iron cores of most induction coils laminated? A. To reduce the core reluctance. B. To increase the core permeability. C. To reduce the effects of eddy currents. The correct answer is C. The iron cores of most induction coils are laminated to reduce the effects of eddy currents. Here's why. Eddy currents. Eddy currents are circulating currents that are induced within a conductor when it is exposed to a changing magnetic field. When an iron core is used in an induction coil, the alternating magnetic field generated by the coil induces eddy currents in the core material. These eddy currents can result in energy losses in the form of heat, reducing the efficiency of the coil. Lamination. To minimize the effects of eddy currents, the iron cores are typically constructed using laminations. Laminations are thin layers of iron that are insulated from each other. By dividing the iron core into laminations, the path for the eddy currents is disrupted. The insulation between the laminations prevents the eddy currents from flowing freely, reducing their magnitude and minimizing energy losses. 8895. Certain aircraft use AC electrical power for all normal operation and battery-furnished DC electrical power for standby emergency use. In aircraft of this type that operate no DC generators, the batteries are kept charged by A. Inverters which use the aircraft's AC generators as a source of power. B. Alternators which use the aircraft's generators as a source of power. C. Rectifiers which use the aircraft's AC generators as a source of power. The correct answer is C. In aircraft that use AC electrical power for normal operation and rely on battery-furnished DC electrical power for standby emergency use, the batteries are typically kept charged by rectifiers that use the aircraft's AC generators as a source of power. Here's why. AC generators. The aircraft's AC generators, driven by the engines or auxiliary power units, APUs, produce alternating current, AC, electrical power. These generators supply power to the aircraft's AC electrical system, which is used for normal operation of various equipment and systems. Rectifiers. To charge the batteries and provide DC electrical power, the AC output from the generators is passed through rectifiers. Rectifiers are electrical devices that convert AC voltage to DC voltage. They allow the AC current to flow in one direction, effectively converting it into DC current. Battery charging. The rectifiers receive the AC power from the aircraft's generators and convert it into DC power suitable for charging the batteries. The rectifiers ensure that the batteries receive a steady and controlled charging voltage, maintaining their state of charge and readiness for standby emergency use. 8896. The voltage in an AC transformer that contains twice as many loops as the primary will be. A. Greater and the amperage less than in the primary. B. Greater and the same as in the primary. C. Less and the same as in the primary. The correct answer is A. A transformer that has a secondary winding with twice the number of turns, loops, compared to the primary winding will result in a secondary voltage that is twice the voltage of the primary. This relationship is based on the principle of electromagnetic induction, where the voltage is directly proportional to the number of turns in the winding. However, it's important to note that the current in the secondary winding will be inversely proportional to the turns ratio. In this case, where the secondary winding has twice as many turns as the primary, the secondary current will be 1/2 the current in the primary winding. This is due to the conservation of energy, where the product of voltage and current remains constant in an ideal transformer. Thus, while the secondary voltage doubles, the secondary current is reduced by half compared to the primary current in a transformer with a turns ratio of 2:1. 8897. If the positive field lead between a generator and a generator control panel breaks and is shorted while the engine is running, a voltmeter connected to generator output would indicate A. Zero voltage, B. Residual voltage, C. Normal voltage. The correct answer is B. If the positive field lead between a generator and its control panel or voltage regulator breaks and shorts to ground while the engine is running, the generator will only produce residual voltage. With both ends of the field at ground potential, there is no field current, and the armature windings can only cut the magnetic field caused by the permanent magnetism in the generator field frame. This residual magnetism generates a residual voltage typically ranging from 1 to 2 volts. It is crucial to address the issue and fix the positive field lead to restore proper field current and enable the generator to produce its normal operating voltage. 8898. What is a method used for restoring generator field residual magnetism? A. Flash the fields. B. Reseat the brushes. C. Energize the armature. The correct answer is A. Restoring generator field residual magnetism is commonly achieved by flashing the fields. This method involves momentarily applying a direct current, DC, to the field windings of the generator. The DC current creates a magnetic field in the generator's rotor, which helps restore or enhance the residual magnetism in the field poles. Flashing the fields is typically done by connecting a temporary DC power source, such as a battery, to the field terminals of the generator or through specific procedures outlined by the generator manufacturer. The duration of the DC current application is typically short, usually a few seconds or less. By flashing the fields, the residual magnetism is re-established or strengthened, which allows the generator to generate its own output voltage when the generator is brought up to speed and the field circuit is reconnected.